Thanks to the Bessemer DAO for hosting this conversation. So by way of background, my name's Morgan. As mentioned, I work primarily on the healthcare and life sciences team here at Bessemer. So you haven't seen me on the crypto conversations, but I've been a huge, I would say, crypto optimist, to use Lindsay's term here in the chat, for many years. And at very early on, really started to think about what are going to be the applications in my industry, notably healthcare and life sciences, where we are known for adopting technology 10, sometimes 20 years later than consumer gaming and others. And so it's my pleasure today that we're going to be talking about DeSci, or decentralized science, which is essentially a burgeoning area of the Web3 movement, exploring how scientists and entrepreneurs can increasingly leverage blockchain technology, smart contracts, tokens, and other tools to improve modern science. And I thought no better person in the industry than one of the founding leaders himself, Niklas, who's here with us today. And I'll read everyone his formal bio, but then we'll quickly pass to him to give us his own take on his journey and really how he got involved in DeSci. So by way of background, Nick is a physician scientist and founder of Lab, an online community of life scientists collaborating to increase the accessibility of life science tools, both in the dry lab and wet lab. His prior research at the Broad Institute, the German Cancer Research Center, and ETH Zurich was focused on improving treatment recommendations in precision oncology, based on image-based profiling of compound effects in patient-derived organelles. As a Fulbright scholar, he received his master's degree in biomedical informatics from Harvard Medical School in 2019. The title of his thesis under Jesse Boehm at the Broad Institute was Living Biosensors, Predicting Drug Vulnerabilities from Living Tumor Samples by Single-Cell Label-Free Imaging. So thank you and welcome, Nick. We'd love if you could kind of fill in some of the gaps in the bio for us here and tell us a little bit about your journey as to how you got into.
Thank you so much, Morgan, for that introduction. And thank you everybody for having me. I didn't know there was a Bessemer, but this is extremely exciting. And I'm glad to talk about DeSci. I think this was a very long bio, so I think there are not a lot of gaps here. I think what might be interesting to answer are two questions, which is the first one, what is DeSci, and then how do you go from being in academia to spending your day on a Discord and doing this weird thing called DeSci. So I think about DeSci as an extension of the open science movement. And so about 20 years ago, and I actually don't have the exact timeline in my head, it became more and more popular among scientists to ask the tough question of who owns the outputs of a scientific study. Why is the publishing industry as complicated and ineffective as it is right now? So for example, these scientific publishing agencies, they operate a very large margin and basically are gatekeepers and aggregators, so curators and gatekeepers for scientists to publish their work. In a world where everybody can just post something on Facebook, why am I still being gatekept to publish my scientific output? And then also everything that's related to software, data, or IP, why is the sharing around these types of information always so difficult, both in terms of the publishing side, but also claims on IP by the universities and wherever the science is being done. And while open source was a huge inspiration for the open science movement, I think open science really is now undergoing a sort of a next evolutionary period where it's also open source payments. So Web3, the ability to assign property rights using open source mechanisms, that is now giving the open science movement a new spin, what we call decentralized science. Basically open science with a bit more teeth, where scientists can actually own pieces of something, such as IP or a revenue stream. Now, within decentralized science, the core idea is, well, what if we were to live in a world where everybody on the internet could raise the funding for doing science that they need, without going through some credentialized pathway, without being affiliated with a particular university that allows them to apply for NIH funding, and without any eligibility criteria to be able to apply for funding from the NIH. That's phase one, that's the funding layer. And then there are two other layers, which is the execution, where and how does the science happen, and with whom, and then also how does the science get distributed. And in the decentralized science vision that we have here is that not only are you able to raise the funding for wherever you want it to come from, but you also want to be able to work on the scientific project with whoever you want to work with, because what you're doing is most of the time really in the public goods interest. Or if you have a private entrepreneurial that you want to take, you can also obviously pick your team and be more intentional in that direction. And then when it comes to the distribution, you want to own the fruits of your labor, the IP that you might generate or the algorithm that you might generate, and then you want to host for at cost services. So that's the DeSci stack: raising funding in a new way, doing science in a new way, distributing the outputs in a new way. And yeah, that's why I quit academia and I'm now doing this thing.
It's an awesome overview, and thank you for the background there. And for those who aren't familiar with the open science movement, we posted some links in the chat below and more about Niklas's background as well. Niklas, as you talk about the different layers of the DeSci stack, I think it's important to note that there is no kind of like monolithic holy opportunity here. There's opportunities across reimagining how we think about scientific reputation, right? Thinking about alternatives to the H index, for example. We talk about, mention opportunities for funding and capital allocation. Some of these vehicles could potentially disintermediate the traditional role of the biotech VC, the tech transfer office, et cetera. You noted peer review. We can think about training and mentoring, and then what you're building at LabDAO cuts across a number of these different areas, but is also thinking about the fundamental infrastructure that's powering the life science industry today, and how we kind of sustain the tooling and that infrastructure over a longer period of time across many nodes of many brilliant people working on these problems. I guess, taking a step back, could you tell us about how you think about these different areas of opportunity, and why, for example, you've committed yourself to working on what it is that LabDAO seeks to bring to bear, and maybe also just give folks a little bit more color on what LabDAO is and what you're building?
Yeah, absolutely. So I introduced these three slices of the pie: the funding, the execution, the distribution of within the scientific process. And I think what might help you add some color to how the DeSci space is looking like right now. On the funding side, you have dedicated public good funding service like Gitcoin, where scientists can also apply next to open source contributors to get funding. But you also have, on the more translational end, DAOs that are underwriting scientific risk. So they're purchasing IP through sponsored research agreements, such as Vita DAO, where I'm a core member. And that is basically, you raise funding through a token sale, and then you, as a collective, you allocate capital into scientific organizations to sponsor research. Then there is the actual doing of the science, and this is where actually I think there's a bit of a gap in the stack. We have relatively interesting projects that are busy and working through funding science. We don't have a lot of actually infrastructure that enables the scientists to say, okay, now I'm actually going to not be at an institute, and I'm just going to be working on a Discord server where other scientists can actually do the work. And really the big question that I wanted to solve was, well, what's stopping scientists from living that way, working that way, and what are the tools that we need to build to make that possible? And that's what we focus on at LabDAO. So lab in LabDAO is both sort of focused on the social construct of a lab. If you've gone to grad school, you know that a lab is like 12 people, and there's a PI, and they have like a summer retreat once a year, and there are some like different projects happening in the lab. There's a social construct that's the lab, an exchange of expertise, training. But then a lab also is the physical place where the stuff happens. And we're focusing on computational biology because I'm just dog fooding my own project here, my own space. But in computational biology, you need some cloud infrastructure, and that's relatively easy to get a hold of. That's why we're starting with that. And then once in a while, computational biology goes into the wet lab, and then it's something like expressing a protein or synthesizing a small molecule. And we try to onboard those laboratory services and try to package them in a relatively accessible format so that experiments can be run with them. But for us as scientists, they're presented to the scientists as if they were an API, where I say, okay, this is a small molecule formula, and I want this to be pipetted on this particular cell line, and please give me the viability readout after 3 days of incubation. And I'm not going to touch anything beyond these like input dials. That's the experience I want to create. So that's what LabDAO does. That's what we're building, really starting to build, frankly, now that we're entering through a next chapter within LabDAO. And that's sort of where we see ourselves in the stack. There's this third layer in the stack, which is the distribution. And there are groups that are focused on the publishing of new ways to publish and also new ways to capture IP and distribute that. You probably have heard of Molecule, that basically thought about legal engineering, infinitely transferable exclusive sublicenses that have an NFT representation. That's basically molecule technology. What I want to do with LabDAO is eventually be at a point where if you have the social lab and you have the physical lab, you can also do inventions and generate new IP within LabDAO. And then we will have the dilemma of saying, oh, well, how do we capture that IP? Is there going to be an online community that can file patents? That's something we'll have to figure out, and it's going to be interesting to explore. Yeah, I'm going to stop here. I think that hopefully gives a bit of an overview of how the ecosystem looks like and where we see ourselves.
Hey, Niklas, this is Lindsay. Thank you so much for joining us and doing this. I have the distinct pleasure of working with Morgan every day. So I know, he's the right mind to be leading this on our side. I, on the other hand, am doing everything consumer crypto here, which is mostly gaming, creators, NFTs, DAOs, that sort of thing. And I'm curious, other than maybe the macro interest in crypto, why now is the right time for DeSci in particular? And do you think that it takes increased adoption of some of these other like more mainstream crypto ideas before we get there? Or if funding, I guess I'm just trying to think about the timeline here. And the difference for science too is like some of the more structural barriers that you outlined, right? That the lab is both a social construct and a physical place. The other roadmaps that we work on here, like gaming, don't have. And so curious how you think about the adoption within the industry, and then how we should think as investors about the timeline for some of these things.
Yeah, so this for me both maps into the sort of why now question. Like why does this emerge now, and why is now the right time? I think there's a technical why now. The technical why now is that we basically saw this first NFT cycle where a market adopted non-fungible tokens. Filecoin IPFS is maturing rapidly. We are building clients on top of it ourselves. So I think you're going to be able to do way more useful things with IPFS than just a funny cat picture or a funny dog and then mint a token that's pointing to that funny dog, you or I. So that's moving really fast. We're using pretty, I would say, I think it's fair to say sophisticated IPLD schemas to enable, if you have a set of satellite images, you want to reference the whole satellite image, but you also might want to access a particular X and Y coordinate piece within that object. That requires just a bit more technology that is now becoming more and more accessible. There are more and more people that can do this kind of development work. So that's why on the technological frontier, this is now the next more complicated thing you can do. And it's sufficiently complicated to capture a lot of the problems that you have in science, which brings us to the next why now. Well, science is just becoming increasingly unbearable to work. And you have the available science funding, especially for junior academics, is a very dire situation. Accessibility for young scientists to get funding has rarely been so bad. I think I would now have to come up with the numbers, but everybody that wants to read more about the state of science, and especially for young scientists, should head to newscience.org. That's an organization by a friend of mine and also funded by the Collison brothers and supported. It's basically capturing some of the statistics around how hard it is these days to be a young scientist. And then the third element, the third question to the why now is COVID has shown us that, while it certainly wasn't pleasant, you can actually get good amount of science done from your laptop, and especially computational biologists were able to get a good amount of science done from their laptop. And a lot of us are asking, actually science is oftentimes bottlenecked by the good ideas, and if good ideas can be exchanged on the internet very fast, why should we stop doing science from our laptops? Those are sort of three answers to the why now, and I don't know whether they captured all the two questions that you formulated, and if they didn't, then please come back. But I think those are the three why nows that I see.
That's super helpful. I appreciate that.
I might even add, Nick has been just so early in this space, both of DeSci, but also candidly computational biology and bioinformatics. And as he alluded, increasingly, like when we evaluate biotech companies at Bessemer, having an ML-enabled function or using computational techniques across the drug discovery process is really kind of table stakes now. This is how biotech companies are being built. And so I think just this burgeoning cohort of folks who are self-identified as computational biologists and who are multilingual, who speak the science of computer science, but also understand molecular and cellular biology is only growing and creates a bigger pool of individuals who can engage in the DeSci ecosystem, which I think is really interesting. Niklas, I think one thing that's very nuanced about life sciences in general is that you're kind of spanning two different worlds that are often in opposition, one being academia and one being kind of, industry, biotech and pharma, and kind of having separated a little bit from academia as you sit in the DeSci ecosystem, straddling both of these worlds. What's some of the feedback you've been hearing from the academic community, and what are some of the either biggest barriers to adoptions or potentially criticisms of DeSci that you all experience and are navigating?
So a criticism that I've heard next to, I think, just general FUD about crypto from people that haven't looked deeper into it was that there was a general fear about science becoming even more financialized. And I think when I hear this criticism, my first gut reaction is, well, it always has been about money. There were just institutions that were created to make you feel like it was not that much about money, but about the citation counts that you have, which then map into money. So actually, maybe this is good news that it's so obvious that it's about money, because now you can be innovative yourself and in the way that you collect the money that you need to do your science. And I think however, there's a bit more nuance to it, where people are concerned that their science will just be seen as an NFT artwork that's being generated, and people will be flipping these NFTs. And I think some scientists might take issue with that, of being subject to speculation. And on that front, what I would say is that there is an increasing number of also philanthropists within crypto, and Gitcoin, I think, is a great example where if we build the right infrastructure, I think that we can live in a world where scientists can choose how they want to raise their funding. Do I want to be a basic scientist? Do I want to stay in a realm where I don't want someone to take a financially motivated bet on owning the IP of my scientific output? And I focus on maintaining a pristine reputation and creating a lot of open source work and raising my funding through Gitcoin and other funding agencies? Or am I going to be more of an inventor type, or even an entrepreneur, and I'm going to actively generate IP that has commercial value, and I'm going to market that to a group of potential owners that want to share some of the upside of either, if I'm an entrepreneur, the company that I'm going to spin out of it, or if I'm more of an inventor type, the IP that will generate, that will then eventually, with the right team, lead to a company that will emerge. So I think that the nice thing, or but put more professionally, the hope that I have about what DeSci means to the way that we do science is that everybody can choose their own adventure, and that this one class of scientists that I think has been really underserved in the current ecosystem, which is the inventor, the one that is not a basic scientist, but also doesn't want to be an entrepreneur and work on the one company for 10 years, but rather generate 50 interesting ideas within 2 years. That character, can, I think, find their own path within that DeSci ecosystem.
It's really insightful. And others should feel free to jump in. Sorry.
Hey, Morgan. Hey, this is Vic. Hey, how you doing, man? Good to see you again. One thing I forgot to ask when we last met on this NFT topic, because obviously the use case for NFTs is very broad beyond art and collectibles. Have you thought, or are you going to incorporate like an NFT as the representation of the IP, so that it's it's unique, it could be transferable or not? But have you thought about that, or are you already doing that?
Yes, so that's definitely something that's on the part of the legal blocks that we want to use. So if you have you have the web lab. The web lab, basically a group of scientists that work together, they generate these data assets. They are tokens, and eventually they can be bundled into a package of data. And then if we choose to, and if we think it's something that the market wants, we can then also file for basically terrestrial legal protection. And then it's an IP NFT. Otherwise, it's just a bundled NFT that gives you access to a data vault that nobody else can read beyond, except the person that has purchased this NFT that gives them access to the secret information. I think frankly, we'll have to see where the dust settles. I can also see basically just these teams spinning out biotech companies the good old way, raising equity funding, be it through Web3 tools or not, like a Web3 SAFT or SAFE. That I think that this is not 100% clear yet. I'm a big fan of tokenizing IP or scientific data, and I'm planning to do it, but we'll have to see what, you know, the investor appetite is going to be for these type of scientific projects.
It makes sense. Thank you. And then a quick, sorry, one more, because I know we were jamming on it. Have you given more thought about that concept we talked about, where you, within Lab DAO, the way that it works now is kind of general, although your audience is computational biologists and computational genomics people, but to narrow and focus in on that category, you know, because you can imagine, just if you look at Lab DAO and you abstract away the focus area, you could see it being a marketplace for any type of work, you know, of intellectual worker, right? But have you given more thought to what we talked about, which is like, you know, the domain specific, you know, protocols or algorithms or tooling inside of Lab DAO that makes it a, you know, a heat seeker for this category of folks?
Yes. So on the computational side, what we do is we integrate, for example, the exchange relatively deeply with Nextflow, which is a workflow descriptor language that's very popular among computational biologists. That's definitely one thing. Another thing that we have now started doing is basically make sure that we as a core team maintain reference genomes that are content addressable, so that you can use IPFS and reference like a genome or a particular data set, the biomedical data set, using content IDs, and we host that. So we already bring some basically tools to the party, and they're all bio themed. So if you're into science and if you're into computational biology, you come to Lab DAO because we maintain all these tools. You wouldn't go and offer that work somewhere else. Beyond that, I think there's also the social element, right? So we try to maintain and build a community of scientists. So we also actively engage scientists, especially students at universities, and that will only accelerate in the next coming months. So it's also who is already doing it will be heavily leaning towards student scientists. And I think those two factors will then drive the adoption of the particular niche that we're looking for.
Awesome. Thank you.
Niklas, one thing we talked about, you know, earlier in our conversations is really like the current state of software maintenance, for lack of a better term, in the academic setting where bleeding edge discoveries are being made. I mean, maybe for this group, it'd be helpful for folks to understand some of the challenges around, you know, deprecation when folks progress through their training and eventually like potentially go into industry or other areas, and then maybe talk about how, you know, what you're building at Lab DAO and how the broader DeSci ecosystem can help address some of these infrastructure failings we've seen.
Yeah, absolutely. So I think one good story to tell when we talk about open source software and science or in biology in particular is to compare and contrast it to how open source in industry and the tech industry works. So let's just use Kubernetes. So Kubernetes is developed at Google, if I'm not mistaken, internally. It's an extremely useful tool to orchestrate like container workflows. Then Google maintains it. Google pays engineers to maintain it. They open source it. Why? Because it's such a useful tool that eventually, if they share it with everybody, everybody can contribute to improve it gradually. And then at some point, it might become even too much work to Google to only pay the developers to maintain it full time. So they set up a foundation, or they transfer it to the Apache Foundation, and then all the other companies need to pay engineers to maintain the tool as well. Plus, there's one non-Google affiliated entity that's maintaining the IP and does some of the governance work. Now, in science, we don't have that. In science, there's a grad student that as part of their PhD is writing a piece of software. They then publish a paper, and that's really the finish line. The paper is published. Now the incentives are completely misaligned between the student wanting to leave academia to go into industry or like to become a professor, and this algorithm to be part of the sort of commons of that is basically human progress is built on science. So if this algorithm should contribute to human progress, but oftentimes it doesn't because it's not well maintained. It's written in Perl. Nobody's using Perl. It's getting outdated, and eventually it's completely useless. Now, people are trying to mitigate this and are trying to apply for grants that are dedicated to maintaining these tools and software, but they're extremely hard to get because the scientific funding system is is sort of following the publication cycle. So you raise funding, you then publish a paper, and then you raise new funding for the new paper. You don't raise new funding to maintain the stuff you did in the old paper. And that is what's fundamentally misaligned around the way that scientific software is being maintained. You need to be able to raise funding to maintain the old stuff. And this is currently an underserved area in science. Now, what we hope to do is that adding a pull request to a open science tool becomes as cool as being a contributor to the TensorFlow, main branch, or having done a accepted pull request to PyTorch. And I think we can do that, especially if we start with badges and some kind of proof that you've done it. Especially in academia, everything is about something that contributes to your reputation. Something that can be counted is even better. So we're working with Git POAP. Some of you probably know POAP. Then Git POAP is basically you get a POAP for a pull request. So we're probably going to be one of the earlier ones that are not Ethereum correlated to be Git POAP integrated. So we toggle different algorithms that we consider super relevant for scientific progress in biomedicine. And then every scientist everywhere in the world that does a pull request and maintains this tool can get a Git POAP and has a badge. Okay, I contributed to this. Eventually, we hope that the exchange is generating so much fees, the lab exchange, that the DAO can continuously give out also maintainer grants to have people work and maintain these tools full time out of the very selfish capitalist interest of keeping the exchange and the applications on the exchange awesome. And I think with that, we can generate a personal positive externality as well.
May I jump in to ask a question here? So I think something that I'm curious to know is that, have you met more sort of challenges with people that come from more prestigious institutions versus people that don't come from as prestigious institutions? Because something that I've noticed, and I can give an example, I think my brother's in this chat as well. I go to a worse ranked medical school than my brother, and the amount of resources that they had in terms of research and the amount of support that they have behind their stuff is just so much more than what I would have at my institution. And so I was wondering, is there sort of with some of the higher ranked schools, or whether it's the PhD programs, is there something that's sort of they're met with I guess more challenges or more sort of questioning on what you're doing? And then I have a follow-up question from this too.
So to that question, absolutely. So when we talk about our user persona, it's the overly online, under-resourced scientist. So this is not I have a lab at Harvard. This might not even be the I am a senior postdoc at Harvard persona. This is I'm an ambitious, frustrated undergrad at University of Toronto, or this is I'm full professor in Spain or in Brazil where there's not a lot of funding. These are the personas that we're working with, the user personas. And I sometimes think this is just a question of time, right? If you do something crazy that's new, then it's the people that are in a position where they can only take risk or be stuck in a place where they don't feel like their needs are being met that are going to be working with you and going to be part of your community. I think, startups weren't always cool. And there probably was a time where everybody that graduated Harvard would go into investment banking into the city and not go to apply to Y Combinator. And look how the world has changed. So maybe we're seeing something similar right now. At least that's what I hope.
And then the follow-up question to that is, I know with a lot of science and medicine in general, there's a lot of sort of credentialing that goes into things. I know with on-chain, you can sort of have whether it's a graph or a map of what people have sort of accomplished. So are you guys sort of incorporating a system of on-chain credentialing so that someone from, for example, you mentioned, from Spain, from this X university does X, Y, and Z, and then how can they be mapped on-chain for their credentialing?
Yes. So this is actually going to be a core activity we want to focus on-chain reputation. So we want to, basically, this is also a cultural statement. So we want you to have a disproportional reputation score if you have done a lot of Git POAPs by maintaining scientific software over you did one more master's degree. But I think it's definitely going to be the case that we haven't done this yet, but we're looking into it actually right now, into finding mechanisms to validate that someone has a particular diploma or has gone to a particular training, and then issuing a token and a POAP that says that they've done that training. We do this right now internally at LabDAO for operation security training. So if someone has done through the cybersecurity bootcamp, then they get a POAP and they can attach that to their CV. And we're going to be rolling that out for a lot of other more courses and degrees. But that's definitely on the timeline. Yeah.
Thank you.
So I recognize we're a little over halfway through the conversation. Just wanted to pause and see if any others had questions they haven't been able to ask yet.
I have one actually. So I'm just thinking about, thanks Niklas for being here. Just thinking about governance in your DAO, right? So like, I know I worked in labs and pretty much it's dominated by the lab leaders, and the research is pretty much dominated by, hey, I'm really interested in this area, I'm going to do that, right? So how does that work? Like, how do you see this going forward, right? Like if you have this, I don't know, DAO that does some certain research, like how is this governance going to work out in the future?
Yeah, I think this is actually the perfect question after Rima's question, which is, once you have these tokenized like artifacts of reputation, you can start thinking about a scoring system. And that's actually something where DeFi helps. I don't know whether people are familiar with DegenScore, where they looked at your on-chain trading history and then they gave you a score of how degenerate of a gambler you are. Now you can basically do something similar where you say, okay, well, what are your credentials? What are your Git NFTs, the university courses you've taken, and then that gives you not a Degen score, a region score or a DeSci score, and then your voting power, like your lab token voting power, gets multiplied with that sign score, and then when there's a governance proposal, there would be a vote on it. So with I think the implications of my answer are, well, are you just going to re-implement the oligarchy that we have in academia today? And the short answer would be, yes, it would probably look relatively similar, where very accomplished scientists would be the whales. However, I think the one thing that would be very, very different is if you don't like it, it's very easy to leave and set up your own lab. And this is the whole idea with DeFi. If you're not happy with your bank, you just go and you find your own mechanisms to take custody of your funds and manage them. And in DeSci, it would be, I'm not happy with my PhD advisor. Well, what is a PhD advisor in DeSci anyway? I can launch my own lab, or I can work in 4 different groups at the same time. I can maintain 3 different Git repos and build my reputation. We're changing the rules in that extent. Not that accomplished scientists, just like whales in DeFi, have a lot of power, but that whoever does not like what they're doing can just exit very quickly. And that's what the internet is good for.
Yeah, just building up on that, mentioning the IP, because I work with a professor and he basically has a contract that says, hey, whatever I do in this university is the IP right of that university. And how does that translate to a DAO? Let's assume like, we created this DAO, we're working on this project with other people, but then the university comes in and says, hey, well, you just signed the document in the real world that says this is my IP, right? So how do you see that going forward?
Yeah, so this is going to get somewhat challenging, and I don't have all the answers of how we can negotiate with the universities on like IP ownership between the DAO and the universities. The universities are going to clamp down on their scientists. They're not going to come our way in any direction unless we also concentrate capital. If we concentrate capital, or if these scientists organize across these different institutions, especially if they organize across these institutions and then capitalize themselves, and then the organizations are the ones that are holding them back from using that money, then we have the leverage we need to then talk to universities. And there's one university that I have in mind right now where this is something that we're looking at, is the tables turn a bit and we have a better negotiating position, but it's too early to say where the dust is going to settle there. Worst case is every scientist in the world will just have a very much better, best alternative to no university affiliation. People will be thinking much harder about, what am I signing here when I'm joining as a faculty, and that's exactly the pressure I want to exert. And if that's sort of the mission I'm on, right? Like build an ecosystem where every scientist can do the science that they want, and then we capture IP by actually just contributing to the formation of the IP. And if that is a competitive deal to more and more scientists, then I hope we might even see some kind of exodus over time. That remains to be seen.
Just to continue on that, is there like a legal framework you wish was already in place on Web3? And any way or that you would see Web3 should protect against potential hacking behaviors?
Okay, so the first question is legal frameworks that we have. So I just spent all my legal brain energy on the fundraise that we just finished. But the next big thing to work on is actually how do we manage IP ownership if people within LabDAO coordinate that have cross institute affiliation. And I think something that there are some precedents for this. So there are university professors that have double affiliations. So for example, at my last institute, they had a affiliation in Heidelberg, but they also had an affiliation with Stanford. And then they usually had like small groups living in each of these two, working at each of these two institutes, but they had their office in one of these two institutes. I think there's something we can learn here where maybe there would be a split in the IP, where the IP that you generate within LabDAO with your lab at LabDAO, that remains with LabDAO, and the IP you generate with your home organization, that with the students that are your home organization students, that remains with the home organization. And then probably that will be the compromise that we have to find with these organizations. And over time, if we do our job right and we just create a better experience for scientists to do their work, and they can find more talented students, then we will see a shift towards LabDAO. So yeah, I think we will have master service agreements for that eventually, but we'll still have to do work there. In terms of other primitives, legal primitives that are existing in the field, at VitaDAO, we use the molecule IP-NFT framework, these infinitely can be highly transferable exclusive sublicenses. And I think that's going to be that's a useful legal primitive, but the jury is still out on these, on all of these DeSci related legal primitives. You had a second question. Oh yeah, the hacking, the security considerations. Yes, so we take this very seriously at Lab, but I think there are a lot of other projects where the security considerations are more heterogeneous. I think that especially when all the protection you have for your secrets is literally just cryptographic, everybody needs to become more aware of the cybersecurity risks. So in the early stages of a project at LabDAO, for example, if you would have a group of scientists, a group of wallets that would, for example, be united through a multisig, and that multisig then holds a token, and then via threshold encryption networks has access to a set of files on IPFS, or using UCAN permission management. In each of these cases, this is pretty advanced technology, and if the scientists mess it up, or if we mess it up by like building the product for it, then all that IP would be instantly visible, and there would be no way to protect the information because it's publicly available. So that's definitely a huge risk and something we need to fix. And I'm a physician by training. I have a huge itch to like just jump right straight to patients and do patient genomes and like MRI and patient records on blockchain, but we're not there yet by far. We need to be able to do like secure mouse genomes and secure X-rays of cells before we can do anything touching medical data with Web3 anytime soon. And so that's where we are. That's the transition.
Niklas, I'm so glad you just mentioned your experience as a physician scientist working in this space, because I think, a lot of our questions around applications of decentralized architecture in healthcare and life sciences obviously comes back to what the impact is, right? Are we measuring our success in utilizing these technologies based on the time it takes to develop new drugs? Are we measuring success based on the care that we receive as patients? So would love, as we think about the other stakeholders in this ecosystem, to hear any thoughts you have on the role of, let's say, pharma and biotech industry generally in interacting with the DeSci community. And then ultimately, we've seen a few projects, namely organizations like Vibe Bio, for example, starting with the patient. Longer term, where could you see things going on the patient side as well?
Yeah, so let me start with the patient question. So patients organizing around either a shared pain and then concentrating capital to like find a for-profit company that can do research in that particular area or build a nonprofit system that offers some kind of support. I think that's definitely something we're going to see more and more of. It's not what we at LabDAO focus on, but I think it's extremely important because I hope that there will be more and more patient DAOs that eventually will want to work with scientists in web labs to then support these scientists working in web labs to like do science for them in these new form in this sort of new way of doing science. The second way that I think patients will come together is not only to concentrate capital, but also to concentrate data. And that one is something I'm pretty interested in personally. So patient data commons. One CT scan alone is not very interesting when it's a patient that has, for example, a liver metastases. But if you have a data set of 5,000 patients with liver metastases, now you have a training data set for medical imaging or some kind of prognosis algorithm. And that has basically a non-linear relationship between the amount of data points that you have and the value that the overall data set has in financial terms. So now this gives you leverage to concentrate the data assets the moment that we have the technology to concentrate them in a safe way and then provide them to for-profit entities or other scientists in return for either like financial rewards or revenue share or citation. So those are the two vehicles in which I think scientists will come together. And I'm sorry, patients will come together. That was the second part of your question. Your first one was generally about the role of biotech and pharma. I hope that we can generate a ton of new biotech entrepreneurs through this, where it starts as something you do on a Friday evening with folks that you haven't only met online, and eventually you tinker and you figure something interesting out, and it turns into something that is more serious than everyone on the team expected, and you start doing this company thing instead of going for a postdoc. I think that would be pretty amazing. Beyond that, I also think that companies, especially larger ones, could become purchasers of particular IP, and then be eventually also users of some of the services that we offer in the exchange, although I think that will still take a bit of time. One more point that I'm going to just add to this, it's not answering your question, but it's something that's just important to me in this context, is one of the frustrations I had as a scientist, especially physician scientist, always was when it came to machine learning, that even if you train a machine learning algorithm on a public data set, like Mimic is this big ICU data set maintained at MIT. It's a great resource. And even if you did that and you published the algorithm, there was no guarantee that it was ever available to anyone, even if you showed that it had some kind of benefit, because there's this very big gap, even for something as simple as a Python script, to go from I publish this to it can touch patients. And in this case, it's obviously running a clinical trial and validating it, but then also B, how do you integrate this in any form into like an Epic or Cerner experience so that it can be called up. And I think this is basically a coordination failure, where if there was one standard to which these data were consumed and these algorithms were served, then you could have an integration, for example, using Fire to consume these biomedical services. So the future that I want to live in is that I'm a physician scientist. I design a new risk score using machine learning tool. Then I publish a paper about it. Then I take this open source repository and I clean it up so it is so it conforms to the lab standards. And then it gets posted, it gets put in a container, and multiple contributors all over the world start hosting the thing. Duke, NYU, other centers just start hosting the thing because that's what we do. It's a standard, it's super easy to do. It's one click. And suddenly you have an internet of like distributed inference nodes that all serve this new medical algorithm that has been completely open source and been developed by a community of physicians. And then whatever the current big UI is for for medical records, they just need to speak one language, which is the language of this API system and how it integrates with FHIR or whatever the current interoperability standard is. And then there could be this whole like continuous integration from I published the paper, here's the link to the GitHub, to this is Dockerized, this is served on the Lab Exchange, it's completely open source, and there's a backend integration into the current front ends that we use to take care of our patients. Okay, this is sort of projecting 10 years into the future, but this is what I want to see.
I love it. I love it. Being mindful of our time again, fewer than 10 minutes left here. Any other questions we haven't gotten to from the broader group before we conclude?
Yeah, I have a question around what's like the biggest piece of infrastructure that we need. And by the way, thank you so much, Niklas. This is super interesting. But yeah, I mean, I think we're iterating more on the incentives, the governance, right? And how we're funding research and stuff like that. I'm just wondering, what are we missing from an infrastructure standpoint to actually make this all happen?
I think we still need to do a lot of work on building effective reputation systems. We're just starting with that. And then the second element is building. The jury is still out on decentralized data storage with access control. It's surprisingly hard to build. There's like a lit protocol, but I hope there are no conflicts of interest in this chat, but we have some concerns about the security of lit protocol, and we're going to be having to like look for other options or develop our own ones. Hopefully we don't have to do the latter, but basically there's still going to be some work involved into creating access control for decentralized file storage that's really robust, and that's a core primitive to make this whole story that I told you become a reality. And then I think more down the line is, the jury is also still out whether we can create open source protocols that allow laboratories to offer services at scale, and whether those economics, these crypto economics, also still work when they touch physical labs. That's something that we'll also just have to prove or like experiment and then see whether the hypothesis is true or not. Yeah, I hope that answers the question. So access control to decentralized file storage is definitely one of those bigger ones where there's right now a bit too much optimism, and then the others are, I think, a bit more in the future.
Yeah, and then thank you.
Hi, Niklas. Thank you for all of the conversations and topics. Would love to get your perspective on what I would describe as like traditional academics and their reception to this space, your work, the key drivers that Web3 is like potentially unlocking, and that like are they scared, worried, excited, but like definitely laggards in their respective fields in terms of adoption? Have you been surprised by any specific industry or sector that's been like overly receptive or quite excited by the space?
Yeah, I think there's definitely a bias towards computational scientists. Like these are the ones that notice it first. They hear about DeSci because they spend a lot of time on their devices. I do think that there's still a general skepticism, and I think that skepticism is absolutely deserved because we haven't built something that's useful for full day working scientists. There's currently nothing that we have built that is useful for them, and in order to be useful to them, we need to build an exchange and a client that allows them to like run algorithms that their peers have developed. We need to build tools for them to raise funding when they have otherwise a hard time to raise funding, and manage contributions. So yeah, generally still skepticism, but curiosity. Everybody is generally curious. If you talk to them more than a minute about what you're doing and they realize you're actually pretty serious about it, then they all want to learn more. And then it's mostly the reason why they haven't heard about it and are taking part in it yet, because it's not useful to the problems that they have today. And we just have now the mission to change that.
Thank you.
All right. I guess my last question is just for folks in this chat who have been sufficiently intrigued by what has been just an amazing conversation with you, Niklas. What are the best ways for folks here to get involved in the DeSci community? And even maybe more specifically, as a second question, how can they support your work at LabDAO?
Amazing. So we have a Twitter at @lab_DAO. We have a Discord that's also relatively active. We try to keep the Discord as if it was the entrance hallway of a university. So there's a lot of chatter about all of different stuff. But then if you have a particular interest, we want you to either find a lab. And when we talk about lab, it's a channel of people that have a shared interest, lab that targets a particular disease or a particular method, or if the lab that you're interested in doesn't exist, we want to help you launch that lab. So those are the three things that we can offer, and that how you can support us. Join the Discord, follow us on Twitter, and if you don't see a lab that you're interested in, let us know and we can help you launch your own.
Fantastic. Well, I think that's a great note to end on. Kieran, I don't know if you wanted to wrap, but I just want to say personally, thank you to everyone who joined. This was certainly an easy lift on our part, but heavy for Niklas and sharing all of his thoughts. And just want to thank him again for his time, and for everyone else for expressing interest in what we perceive at Bessemer and the broader ecosystem to be a very exciting application of Web3 over the next few years and hopefully decades.